For decades, Pluto was just a point of light. It was a faint, solitary wanderer at the edge of our known solar system, discovered in 1930 by a young astronomer named Clyde Tombaugh. For most of its life in our collective imagination, it was a mysterious, frozen outcast. We knew so little. We could only guess what its surface looked like, what secrets it held so many billions of miles away. It was the last of the classical planets to remain unexplored, a final frontier in our initial reconnaissance of the Sun's family. We imagined it as a simple, inert ball of ice and rock, frozen solid by the unimaginable cold of deep space, a place where nothing ever happened. But you know, the universe often has a way of surprising us. It challenges our assumptions and expands our understanding of what is possible. The story of Pluto is a perfect example of this cosmic lesson. We thought we had it figured out, a tiny, forgotten world at the fringe. This distant dot, which we demoted from planethood in 2006, was about to reveal itself in the most spectacular fashion. The journey of a small, determined spacecraft would transform our perception, replacing the blurry pixel of our telescopes with a world of stunning complexity and unexpected vitality. Pluto was waiting for its close-up, ready to challenge everything we thought we knew about small, cold worlds. The reclassification of Pluto as a dwarf planet by the International Astronomical Union was a moment of scientific controversy. But it was also a moment of discovery. It signaled that our solar system was far more crowded and diverse than the neat 9-planet model we grew up with. Pluto wasn't the end of the line. It was the gateway to a whole new region of the solar system, the Kuiper belt. This vast realm of icy bodies holds clues to the very formation of our planetary neighborhood. Pluto, as the king of this distant domain, suddenly became more interesting, not less. It was no longer just the smallest planet, but the largest known member of a new class of celestial objects. And so, our quest for knowledge pushed us outward. We needed to see this place for ourselves. We needed to send a messenger across the vast gulf of space to say hello. The questions were many. What was this world really like? Was it truly a dead, frozen relic? Or was there something more? Was its surface ancient and cratered? Or was it being renewed by hidden forces? The answers would have to wait for a daring mission, one that would travel for nearly a decade, crossing billions of miles of empty space, all for a fleeting glimpse of this enigmatic world. The stage was set for one of the great explorations of our time. Sending a spacecraft to Pluto is no small feat. The distances are immense, the challenge is staggering. You can't just point and shoot. You have to play a game of cosmic billiards. NASA's New Horizons mission, launched in 2006, was an engineering marvel designed for this very purpose. It was the fastest spacecraft ever launched from Earth, hurtling away from our planet at over 36,000 miles per hour. It even used a gravity assist from the giant planet Jupiter to slingshot itself toward the outer solar system, shaving years off its travel time. For 9.5 long years, it journeyed through the cold, dark void, a lonely emissary from humanity. The mission was a testament to patience and precision. Imagine planning a flyby of a world so far away that the radio signals, traveling at the speed of light, take over 4 hours to get there. There is no real-time control. The entire encounter, a carefully choreographed dance of scientific observation, had to be programmed into the spacecraft's computers months in advance. The team at NASA had one shot to get it right. If anything went wrong, there would be no second chance. the spacecraft would fly past Pluto and continue on into the Kuiper belt, its primary mission a failure. The pressure was immense, the culmination of decades of dreams and hard work. On July 14, 2015, humanity's wait was over. New Horizons zipped past Pluto, its suite of advanced scientific instruments whirring and clicking, gathering as much data as they possibly could in the few precious hours of the close encounter. The first images began to trickle back to Earth, crossing billions of miles of space to arrive on our screen. And what we saw left us speechless. This was no simple cratered ice ball. This was a world of breathtaking beauty and bewildering complexity. The blurry dot had resolved into a vibrant, dynamic landscape that defied all our expectations. It was a moment of pure discovery, a collective gasp of wonder heard around the world. The data collected by New Horizons was a treasure trove that scientists are still unpacking today, a decade later. It was more than just pretty pictures. The spacecraft measured the composition of the surface, analyzed the thin atmosphere, and mapped the terrain with incredible detail. It revealed a world that was not frozen in time, but geologically alive. It had weather, it had flowing glaciers, and it had towering mountains. Pluto, the forgotten planet, had just become one of the most fascinating objects in our entire solar system. The little spacecraft that could have delivered a scientific jackpot, rewriting the textbooks on planetary science. Among all the stunning images sent back by New Horizons, one feature immediately captured the world's imagination. Sprawled across one side of the dwarf planet was a massive, bright and remarkably smooth region, shaped uncannily like a heart. This was not just a charming coincidence of geology, it was a profound scientific discovery. This feature, officially named Tombor Regio in honor of Pluto's discoverer, with its western lobe dubbed Sputnik Planitia, became the symbol of Pluto's unexpected complexity. It was a declaration from a distant world that it was far from dead. The heart of Pluto was, in a very real sense, alive. Sputnik Planitia is vast, stretching nearly 600 miles across. It is a gigantic basin filled not with water ice, but with a colossal glacier of frozen nitrogen mixed with carbon monoxide and methane. This makes it the largest known glacier in our entire solar system. Its surface is strikingly smooth, almost entirely free of the impact craters that pockmark most other ancient surfaces in the solar system, like our own moon. The lack of craters is a dead giveaway. It tells us that the surface is young, geologically speaking. Something is actively erasing the scars of cosmic impacts, constantly renewing and resurfacing the landscape. The key to this renewal lies in a process called convection. Think of a pot of boiling water, where warmer water from the bottom rises, cools at the surface, and then sinks again. A similar process is happening on Pluto, but with solid nitrogen ice and on a timescale of hundreds of thousands of years. The surface of Sputnik Planitia is broken up into large polygonal cells, like the cracks in drying mud. These are the visible tops of slow-churning convection currents within the glacier. Warmer, more buoyant nitrogen ice from deeper in the basin slowly rises in the center of these cells and spreads out, before cooling and sinking back down along the edges. This slow, relentless churning is what keeps the surface of Sputnik Planitia looking so fresh and young. It's like a planetary-scale resurfacing machine, constantly erasing old features and creating new ones. This discovery is shocking because it requires a sort of But Pluto is so far from the Sun, its surface temperature a frigid -380 degrees Fahrenheit. The faint sunlight it receives isn't nearly enough to drive this process. This implies that Pluto must have some form of retained internal heat left over from its formation billions of years ago that is still slowly leaking out and powering this incredible geological engine. When we think of glaciers on Earth, we picture rivers of frozen water ice, carving their way through mountain valleys. But the glaciers on Pluto are something else entirely. While Pluto has mountains made of water ice, which is as hard as rock at those temperatures, the glaciers that flow around them are made of more exotic stuff. The vast ice sheet of Sputnik Planitia and other smaller glaciers found across the dwarf planet are composed primarily of frozen nitrogen. This nitrogen ice is much softer and more volatile than water ice, allowing it to behave like a viscous fluid over geological timescales, even in the extreme cold. These nitrogen glaciers appear to be flowing out of the Sputnik Planitia basin and into the surrounding highlands. We can see where the ice has spilled into and filled ancient craters, and where it has carved channels through the rugged mountainous terrain. It's a dynamic system where volatile ices that sublimate into the atmosphere in some regions can then freeze back onto the surface in colder areas, feeding the glaciers. This creates a global nitrogen cycle on Pluto, similar in principle to the water cycle on Earth, but operating with different materials and at unimaginably colder temperatures. It's a completely alien yet strangely familiar process. The evidence for this flow is written all over the landscape. New Horizons captured stunning images showing the edges of Sputnik Planitia, where the soft nitrogen ice sheet abuts the hard, jagged mountains of water ice. You can see the glacial ice pushing against the base of these mountains, and in some places, flowing in between them like a thick, syrupy liquid. We can even see debris from the water ice highlands being carried along on the surface of the flowing nitrogen, like rocks on a terrestrial glacier. It's a stunning display of active geology on a world we once thought was completely frozen and static. This discovery fundamentally changed our ideas about where geological activity can occur in the solar system. We used to believe that only large rocky planets like Earth or moons heated by the tidal pull of a nearby giant planet could be geologically active. But Pluto has neither of these things. It is small, it is icy, and it is far from any major source of heat. Yet, it has flowing glaciers. This tells us that even small cold worlds can retain enough internal heat from their formation to power geological processes for billions of years. Pluto has taught us that the universe is more creative and complex than our models had allowed for. Beyond the Great Heart, the rest of Pluto's surface proved to be just as surprising. New Horizons revealed a landscape of incredible diversity and rugged beauty. One of the most astonishing discoveries was the presence of colossal mountains. But these are not mountains of rock as we have on Earth. On Pluto, where the average temperature is cold enough to make water ice as strong as granite, the mountains are made of water ice. Some of these ice mountains, like the Norgay Montes and Hillary Montes, rise to heights of over 11,000 feet, rivaling the Rocky Mountains here on Earth. They are majestic, jagged peaks that soar into Pluto's thin, hazy sky. The sheer existence of these mountains poses a fascinating puzzle. How do you build mountains that high on a small world like Pluto? It requires significant geological uplift and tectonic forces, processes we associate with much larger, more dynamic planets. The fact that these mountains are made of water ice and not the more volatile nitrogen or methane ice is also a crucial clue. The water ice forms the bedrock, the crust of Pluto, while the softer nitrogen and methane ices form a veneer on top, moving and flowing around these immense rigid structures. It's a landscape built from materials we consider common, but arranged in a totally alien way. Perhaps even more shocking than the mountains themselves is their apparent age. Just like Sputnik Planitia, many of these mountainous regions show a surprising lack of impact craters. This suggests that large parts of Pluto's surface are geologically young, perhaps only a few 100 million years old, which is a blink of an eye in the 4.5 billion year history of the solar system. The surface is being actively reshaped. We see evidence of fractures, faults, and other tectonic features, indicating that Pluto's icy crust has been, and may still be, cracking and shifting. This world is not a static museum piece. It's a place of ongoing geological change. This activity might even include a strange form of volcanism. Scientists have identified features on Pluto that look remarkably like volcanoes, but instead of spewing molten rock, they would have erupted a slushy, icy mixture of water, ammonia, and other substances from Pluto's interior. This process is called cryovolcanism, or ice volcanoes. Features like the large mounds known as Wright Mons and Piccard Mons are prime candidates. If confirmed, it would mean Pluto has another mechanism, besides its retained heat, for bringing material from its interior to the surface, further contributing to its dynamic and ever-changing landscape. It's a cold world, but it's far from dormant. Before New Horizons arrived, we knew Pluto had an atmosphere, but honestly, we knew very little about it. We had detected it from Earth by watching how the light from distant stars dimmed as Pluto passed in front of them. We knew it was thin, much thinner than Earth's, and composed primarily of nitrogen with traces of methane and carbon monoxide. We assumed it would be a simple, single layer of gas, clinging weakly to the surface. But once again, Pluto had a surprise in store for us. The reality was far more complex and beautiful than we could have imagined. As New Horizons flew past Pluto and looked back towards the Sun, it captured one of the most iconic images of the entire mission. It saw Pluto as a dark silhouette, but its edges were ringed by a stunning ethereal blue glow. This was Pluto's atmosphere, backlit by the distant Sun. And it wasn't a single simple layer. The images revealed an incredibly complex structure with more than 20 distinct haze layers, extending hundreds of miles above the surface. These layers are likely formed when ultraviolet sunlight breaks down methane gas, creating more complex hydrocarbon molecules that then freeze and slowly settle downwards. This atmospheric haze gives Pluto's sky a blue tint for the same reason our sky is blue, a process called Rayleigh scattering. The tiny haze particles scatter blue light more effectively than red light. So, if you were standing on the surface of Pluto, looking up, you would see a faint blue sky. This was a completely unexpected discovery. We had no reason to believe that a world so far from the Sun, with such a thin atmosphere, could produce such a beautiful and complex phenomenon. It adds another layer of intrigue to this distant world, painting a picture of a place that is both alien and strangely familiar. Furthermore, Pluto's atmosphere is not static, it's dynamic. It appears to undergo dramatic changes as Pluto follows its long 248-year orbit around the Sun. As Pluto moves farther away from the Sun, a large part of its atmosphere is expected to freeze and fall like snow onto the surface. Then, as it gets closer to the Sun again, that frozen nitrogen sublimates back into a gas, replenishing the atmosphere. New Horizons caught it at a time when the atmosphere was more extended than expected, suggesting this process is more complex than simple models predicted. There may even be winds and weather on Pluto, shaping its surface in subtle ways over time. Pluto does not travel alone on its long journey through the outer solar system. It is the patriarch of its own little family, a system of at least 5 moons. The largest and most famous of these is Charon, discovered in 1978. Charon is so large relative to Pluto, about half its diameter and an eighth of its mass, that the two are often referred to as a binary system. They are tidally locked, meaning they always show the same face to each other as they orbit a common center of mass that lies in the empty space between them. If you were standing on the Pluto-facing side of Charon, Pluto would hang motionless in the sky, never rising or setting. New Horizons gave us our first close-up look at Charon, and it proved to be a fascinating world in its own right. We might have expected it to be a simple, heavily cratered ball of ice, but instead, we found a world with a violent and complex past. A huge system of canyons and chasms, some of which are far deeper than Earth's Grand Canyon, stretches across its surface for more than 600 miles. This suggests that Charon once had a subsurface ocean of liquid water that later froze. As the water expanded into ice, it would have cracked the moon's crust on a global scale, creating the immense canyons we see today. One of Charon's most peculiar features is its dark reddish North Pole, a feature nicknamed Mordor Macula. Scientists believe this polar cap is made of complex organic molecules called tholins. The theory is that nitrogen and methane gas escaping from Pluto's atmosphere gets captured by Charon's weak gravity. This gas then freezes onto the cold polar regions. Over millions of years, solar radiation processes this frozen methane into the dark, reddish tholins that now stain the pole. It's a remarkable example of planetary interaction, where one world is literally painting the surface of its neighbour across thousands of miles of space. Beyond Charon, New Horizons also got fleeting glimpses of Pluto's 4 much smaller moons, Styx, Nix, Kerberos, and Hydra. These are not neat spherical bodies, but small, irregularly shaped objects, likely resembling potatoes or dumbbells. They also have strange rotational properties. Instead of spinning gracefully, they are tumbling chaotically as they orbit the Pluto-Charon binary system. Their bright surfaces suggest they are covered in water ice. These small moons are thought to be the debris left over from a giant impact early in the solar system's history, the same impact that may have formed Charon itself. They are the remaining pieces of a cosmic collision that shaped this entire system. The story of Pluto's shocking discoveries is intertwined with its controversial status in our cosmic family. For 76 years, from its discovery in 1930 until 2006, Pluto was officially our 9th planet. It was the smallest, the most distant, the oddball at the end of the line. School children memorized its name, and it held a special place in our cultural understanding of the cosmos. But as our technology improved, our view of the outer solar system became clearer, and Pluto's place in it became more complicated. We began to find other objects out there, in the cold, dark region beyond Neptune known as the Kuiper belt. The turning point came with the discovery of Eris in 2005, a Kuiper belt object that was found to be even more massive than Pluto. This created a problem for astronomers. If Pluto was a planet, then shouldn't Eris be one too? And what about the other large objects we were starting to find? Were we about to have a solar system with 10, 12, or even 50 planets? The International Astronomical Union, or IAU, decided to step in and for the first time create a formal scientific definition of what it means to be a planet. This was a necessary step for science, but it was one that would prove to be deeply divisive. In 2006, the IAU declared that a planet must meet 3 criteria. It must orbit the Sun, it must be massive enough to be rounded by its own gravity, and it must have cleared its neighbourhood of other objects. Pluto meets the first 2 criteria easily. It orbits the Sun, and it is a beautiful sphere, but it fails on the 3rd count. Its orbit is full of other icy bodies in the Kuiper belt. As a result, Pluto was reclassified into a new category, a dwarf planet. This decision sparked a fierce debate among scientists and the public alike, a debate that continues to this day. Many planetary scientists, especially those involved with the New Horizons mission, strongly disagree with the IAU's definition. They argue that the clearing the neighbourhood criterion is poorly defined and depends more on an object's location than its intrinsic properties. A world like Earth, if placed in Pluto's orbit, would not be able to clear its neighbourhood either. They argue that a more useful definition of a planet should focus on its geology. If a world is large enough to be spherical and to have active geological processes, it should be considered a planet, regardless of what's in its orbit. By this geophysical definition, Pluto is unquestionably a planet. It's a small planet, a dwarf planet, but a planet nonetheless, with all the complexity and dynamism that word implies. The 2015 flyby by New Horizons was a spectacular success, but it was just a beginning. It was a brief, tantalizing glimpse of a complex world. The spacecraft was only able to map one side of Pluto and Charon in high resolution as it sped past. The other hemispheres remain mysterious, their secrets hidden in shadow. What wonders lie on the far side of Pluto? Are there other features as grand as Sputnik Planitia? Are there more cryovolcanoes or vast mountain ranges? These are questions that can only be answered by a return trip, a new mission that could go into orbit around Pluto and map its entire surface over time. For now, there are no concrete plans for a new mission to Pluto. Such an undertaking would be incredibly expensive and would take decades to plan and execute. However, the scientific community is actively discussing the possibilities. An orbiter mission would be the logical next step. It could study how Pluto's surface and atmosphere change over time, search for evidence of a subsurface ocean, and map the dwarf planet and its moons in stunning detail. The discoveries of New Horizons have made the scientific case for a return trip more compelling than ever. Pluto is not just an object to be checked off a list. It is a natural laboratory for understanding a whole class of worlds. In the meantime, our exploration of Pluto continues from afar. As of today, October 14, 2025, scientists are still poring over the vast amounts of data that New Horizons sent back a decade ago, making new discoveries as they refine their models and analyses. Furthermore, powerful new observatories like the James Webb Space Telescope are giving us new tools to study Pluto from a distance. The Webb telescope can analyze the composition of Pluto's surface ice and search for subtle changes in its thin atmosphere, providing valuable context for the New Horizons data and helping us monitor this dynamic world over time. The legacy of New Horizons is twofold. It completely transformed our understanding of Pluto, revealing a world of unexpected activity and stunning beauty. But it also opened our eyes to the potential of the Kuiper belt. After its Pluto encounter, the spacecraft continued onward, visiting another, smaller Kuiper belt object named Arrokoth, revealing more clues about the building blocks of planets. The story of Pluto is a powerful reminder that there are still wonders to be found in our own solar system, and that exploration is a journey without a final destination. The distant heart of Pluto is still beating, waiting for us to return and learn its deepest secrets.